Okay, so we were talking about the derivative of exponential functions. So let me just review what we have done so far. So we want to complete this table. We have the function here, its derivative here. If it's a constant, its derivative is 0. If it is x to power a, where a is a constant, a goes down, then I would write a to power a minus 1. And then we wanted to start talking about the other scenario, that what happens if a is in the base and x is in the variable. Still, this is missing. We haven't completed that question mark yet. But then we learned about a function whose derivative is equal to itself. So this base is the Euler number. We learned that this is approximately 2.72 if you want to keep only 2 decimal places. And then I told you that in the book, there is also this function. So I don't know, they have chosen to create this function separately, but in principle, this is a generic rule called the chain rule that you will study later in Math 4. But anyway, at the level of Math 3C, you should also know what happens if I have a constant there. Yes, so I want to address this question today, and hopefully if we have enough time, we can finalize this question. Okay, but before that, let me refresh your memory by writing an example, and then we continue, okay? So again, example. So let y be equal to x to the power of 5 plus e to power x minus 12. Determine an equation for the tangent line, for the line that is tangent to the graph of this function at the point on the graph whose x-coordinate is pi, the famous pi number, yes. So I told you that this is a very generic question in Math 3C. A curve is given to you, an x-coordinate of the point of tangency is also given to you. You're supposed to find an equation for the tangent line. The only thing that I can change in this example is the function and the x-coordinate of the point. So this is always the same. Okay, so what should I do now? The first thing is to find, the first thing that you need to write for this question is that you need to understand that any tangent line is a line. So in a generic formula for the equation of any straight line, except of course vertical lines, is of this form. And then you need to answer what is this one and what is this one by reading this question, okay? And then you know that k value, we learned it in Math 3C. So k value is the derivative of the function at point A. So this A is the x-coordinate of the point of tangency. Yes? So this is something generic, so you don't need to write it down, but you need to know it. Okay, so if I want to calculate the slope I need to differentiate my function, and then after the differentiation is finished, I have to replace the x by this x which is given in the problem from the beginning. Okay, so I differentiate this one. So y is equal to x to the power of 5 plus e to power x minus 12. So I want to differentiate it. So you know that I have the sum and the difference of three functions. I know that I have to differentiate this one, and that one separately. But differentiation of this is very simple. You already know that. This is the second formula in that row, in that table. So this becomes 5x to the 4. And then this function is the function we learned last time. Its derivative is equal to itself. And then the derivative of a constant, that's the first row, which is 0. I don't need to write it down at all. And then what I do, I find the k value by replacing the x, all x's in my derivative with this x coordinate, which is given in the problem. So it becomes 5 pi to the 4 plus e to the power of pi. I intentionally chose these numbers so that you don't think you have to put this in the calculator. You have to keep it the exact value unless I mention explicitly that you need to do it in 2 decimal places. So this is not something that I can simplify more. I just keep it like that. Okay, so the k value was a strange number. It was found. And then I need to find m. For finding m, I need the x coordinate of the point of tangency and the y coordinate of the point of tangency. X coordinate is already given. Y coordinate I need to find. Yes? And I want you to understand why we are using. Let me repeat it once more. So if this is the graph of my function, it is completely different from this graph. I don't know. I'm just assuming that this is a curve. And this is a point on the graph, and then I have this point of tangency. So you see that this point of tangency, is on two graphs, yes? On the one hand, it is on the curve itself, and on the other hand, it is on the line of tangency. So it means that the coordinates of this point not only satisfies the equation of the curve, but also the equation for the tangent line, yes? So, okay, so it means that I use the function itself to find the y coordinate, and then when I have the x coordinate and the y coordinate, I plug it here to be able to find m. But I want you to understand, is the idea clear why this is possible to do? Yes? The reason is that this point is on both of these graphs simultaneously. Okay, so what I do first, I calculate y for x equal to pi. So if x is equal to pi, this implies that y itself is equal to pi to power 5 plus e to power pi minus 12. So very strange numbers. So this means that the point of tangency, if I call this point of tangency, has the coordinates. X coordinate is given to be pi, y coordinate, this is this weird number. But we have to work with this number. This is the point of tangency. Yes. And then we realize that this point is also on the tangent line. So it means that if I replace y with the y value and replace x with the x value, and of course replace k with the k value, this should hold. Yes, so then there is only one unknown, I can find it out. Okay, so instead of y, I put this expression, pi to power 5 plus e to power pi minus 12. On the right-hand side, I have k. I have calculated, this is my k, 5 pi to the 4 plus e to the pi, multiplied by the x coordinate, which is pi, and then I have the missing m. So you shouldn't worry about the form of this. This is, at the end of the day, is a number. Pi is the famous pi number 3.14 something, and then this is nearly 2.72. We learned that last session. So this is a number, that's a number, I am just looking for m. But might be we can simplify it a little bit. So for example, here, I would write it this one, I repeat this one, and then I multiply pi inside. So it becomes 5 pi to the 5 plus pi e to the pi. And then I have m. I am looking for m, so I move everything to the other side. So it becomes minus 5 pi to the 5 minus pi e to the pi, and then is equal to m. And I simplify something, not that much, but might be these two. And then I can write, for example, I can factor it EP out. It doesn't matter if you really want to do it, but I always tell that I care about beauty. So I will try to do this something like that. So it becomes minus 4 pi to the 5 and then minus 12, which is m. This is already an ugly one, so let us not make it that ugly, okay? So this is my m. And then we put this in this equation. So the answer that you have to write is to write y is equal to k value is this one. So it is 5 pi to the 4 plus e to the pi multiplied by x plus this m. Okay, so it's a little bit weird, but this is what it is. Okay, but if you want to do some approximations, of course, then you can put these numbers in your calculator. And what you get is a number, and what you get here is also a number. Is that clear? Okay. Now, let us go back and answer this question. But answering this question is still not that easy. Okay, so let me review a little bit before. So do you remember we had this, we started from our question. So the function was a to power x, and our goal is to find the derivative of this function. If you go back and look, at your notes, you will see that we got this. We got f prime of x is equal to the same function, but multiplied by a limit. Yes. So if you remember, this is what we got more or less in the first few minutes of the previous lecture. And then the whole point is that how to calculate this limit. And then I motivated you that there is if I calculate this limit for 2, it becomes a number smaller than 1 roughly. And if I calculate the same limit when a is equal to 3, it becomes a number a little bit bigger than 1. Then this motivates me, might be there is some number between 2 and 3, so that this limit for that particular number is exactly 1. And then we called that the Euler number, yes? And we denoted it with just e, yes? So these are the consequences. So we learned that this limit, at least, for that particular number e, you need to remember these. This is equal to 1. So this is a famous limit. That is actually the definition of e. E is that number so that makes this limit is equal to make this limits equal to 1. And then we manipulate this algebraically a little bit. So if you remember, we did some stuff, and then we got this formula, nice formula for e. So let me write it the other way around. So this is a famous limit that cannot be done with elementary methods. If I have a limit of 1 plus h to the 1 over h goes to 0, this becomes e. This is also a famous formula in mathematics. And then using this formula, we were able to see that e is approximately 2.72 up to 2 decimal places. And then I told you as a passing information that e is irrational. So it means that you shouldn't have any hope to get the exact value in decimal forms. Okay, so these are the things that we had before. Okay, now today we want to start with this one. That is not hard to understand what happens. By the way, let me remind you, I told you that if this function is given to you. If I ask you what is its derivative, you immediately say it is itself. We were able to show that. By the way, why this is the case? Do you remember? Because if my function is e to power x, I replace a with e. Then the derivative becomes e to power x, the limit of e to power h minus 1 divided by h. By that limit is 1. So when I multiply 1 by e to power x, I will get the same thing. So that was the reason that the derivative of this particular function is equal to itself. And then I told you that let us manipulate this a little bit. So there are two ways that we can manipulate it at the level of Mat3C. One possibility is that you might ask, what happens if I add a number to this exponent? That was easy. We were able to answer this one as well. Do you remember? If I want to take the derivative of this function, I told you that you can just write f of x is equal to e to power 5 multiplied by e to power x. But e to power 5 is just a constant. And then we have a famous rule, yes? We have this rule that if I have a number multiplied by a function and I want to take the derivative, then I can differentiate the function and then multiply the answer by c. So that is not a big deal for us. It is just the same. So if I want to calculate this, you need to remember that you can write this in this form and then use that rule to differentiate your function. So what would be the derivative? This is supposed to be a constant. E is constant, 5 is constant, so e to power 5 is a constant. It can play the role of that c. So I will not do anything with this constant, only concentrate on differentiating this function. And we already know that the derivative is e to power x. So that is the derivative again. If you want, you can combine it back. So that is also a function whose derivative is equal to itself. Another way that we learn in Mat3C to manipulate this exponent is to multiply it by a constant. For example, I ask you the same question, but this time I would write e to power, for example, 5 times x instead of 5 plus x. We want to answer this question today. So that is also simple. So let us see what we can do. Any questions so far? That was actually a crash review of what we have done before. So let me clean this and then concentrate on calculating the derivative of that function. Okay, so the question is this. If I have a function of e to power a constant multiplied by x, I want to answer this question. What is the derivative of this function? This is also a little bit tricky. So if I want to do this, I start from the definition of the derivative again. Whenever you want to find the derivative of a new function, there is nothing else that you can do. Yes, you have to start with the definition. Okay, so hopefully you remember the definition of f. The f prime, it becomes the limit of x plus h minus f of x divided by h. H goes to 0, yes? And then this becomes the limit, and I hope that you have enough experience here now. H goes to 0. There is a negative sign here. F of x is my function. Yes, it is e to power cx. But what is f of x plus h? It means that go to your function, replace every x you see there by x plus h. There is only one place that you see x, so you take it off, and then you plug it with a pair of brackets around that, cx plus h. Be careful. If you write in this form, this would be wrong, because then people will interpret this that c is multiplied only by x. That is not what we mean. We have to respect and put the pair of brackets. Is that clear so far? That is just a normal way of doing that. And then I multiply this c inside, so this becomes the limit e to power cx plus ch, and then I have e to power cx. I will follow exactly the same process, but it is a little bit new stuff there. I want to talk about that. Okay, so the first step is as before. So I would write the limit of e to power cx multiplied by e to power ch minus e to power cx divided by h. Okay, h goes to 0. So again, you see there are 3 letters, there are 3 parameters in the problem. But as far as the limit is concerned, which one is the variable here? H. Even though c is a constant from the beginning, x is not a constant. It can changes, but when I am calculating the derivative at a particular x, it means that I have already chosen my x. I am working with that x. But h is still can changes because I am sending h to 0. I am making h smaller and smaller. So h is a variable for this limit. Okay, and then you see that I have the same factor of e to the cx here. I can factor it out, yes? So this becomes the limit e to power cx multiplied by e to power ch minus 1 divided by h goes to 0. So sending h to 0, making h smaller and smaller doesn't affect this part at all because it doesn't depend on h at all. Yes, it depends on on c and x. So as far as this limit is concerned, as I told you before, this is a constant, so I can pull it out and multiply this constant by this new limit. Okay. Unfortunately, this limit is not exactly the limit that we know about. Yes, because the limit that we know has very similar structure, minus 1, h goes to 0, h goes to 0. But unfortunately, instead of having e to some number, which is this number, I have c times that number. Whenever this happens, you can introduce an auxiliary variable. Okay, so I would say let h be equal to ch. I am giving it a new name. Instead of ch, I call it capital H. Yes? But you can tell me, when h becomes small, what do you infer? What do you conclude about capital H? If the small h is very small, what can you say about capital H? Is it big? Is it a small or what? It's also small, yes? Because when h is very small, very, very small, you multiply it by a constant, it becomes again small. Of course, even if the constant is 1 billion, you can make it x, I don't know, 1 over 1 trillion, yes? So it becomes a small, yes? When h is negligible, it doesn't matter if you multiply it by a constant, what you get is also negligible. Yes, that's the idea. So that, what does it mean? It means that when, therefore, when h goes to 0, comma, capital H also goes to 0. Yes, is this sentence understandable? Yeah, these are intuitive ideas. If you want to understand them very fully, you need to go to mathematics university. Okay, but this is understandable. At the end of the day, even if you go to be a math major, they want to do this very rigorously and very precise. But that is the idea behind it. Okay, now let me give this L. I want to calculate this limit L. Okay, let me rewrite L in terms of my new variable. A small h goes to 0 implies that capital H also goes to 0. And then I have this fraction line. In the numerator, I have e to the c times h, but I gave c times h a new name, so I called it capital H. Yes? And then I have minus 1, but I need to replace h with the new name again. But from here, you can conclude that h is h divided by c. Yes? So 1 point. When I say h is h divided by c, I need to make sure that c is not equal to 0, because if c is equal to 0, I am not allowed to divide. But c is equal to 0 is not my problem at all. Why? Yes?
Because h is your variable.
No. Because if c is equal to 0 from the beginning, what would be this function? Well, it becomes 1. And what is its derivative? It's 0. Because 1 is constant, its derivative is 0. Yes? So it means that when I am talking about the derivative, the mysterious point is when c is not equal to 0. Because if c is equal to 0, I really don't need to go through this mess, yes? Because if c is equal to 0, 0 times x is 0, e to power 0 is 1, so my function is 1 and its derivative is 0. So interesting thing happens if this is not 0, yes? So it is very good to emphasize that here, that c is not equal to 0. Okay, so this is one point, and then instead of this little h, I put capital H divided by c. To get rid of this fraction, I multiply the numerator and the denominator by the constant c. Okay, so this becomes equal to the limit. I multiply the numerator by c, e to power h minus 1. What happens if I multiply the denominator by c? That c that I am multiplying with this c will cancel out, and then h is left, and h goes to 0. Agree? And now, again, c is a constant. Yes, I can pull it out again. So this becomes c times the limit of e to the h minus 1, h goes to 0. Okay, now can you tell me what is this limit? Yes?
It should be 1.
It's 1, yes. Because this is the same limit, but the name of the variable instead of little h is capital H. For example, if I ask you take your calculator and guess what would be this number, what do? You set up a table, but this time instead of little h, you would write capital H, and then you would say h is 0.1 and 0.01, and then you calculate these values. And now, if I ask you to calculate this limit, what will happen? You will set up the same table, but you will put a small h. But the numbers that you get here is not sensitive to the name of the variable. It's completely clear that if that limit is equal to 1, that limit is also equal to 1. Is that understandable? Yes or no? Yes or no?
Yeah.
Yes. Okay. And then what happens? This becomes c times 1. So this becomes c times 1, which is c. So this means that my L is c. When L is c, I put it back into this question mark. I had e to power cx from the beginning. I had c here as well. So what happens? It means that the derivative is e to power cx multiplied by this limit. This limit was found to be c, so it becomes c times e to power cx. Yes? So that is the only thing that can happen. Again, c goes down. If you have c, so it is very crucial. Do you remember? If I add 5 to it, it doesn't change at all. But if you multiply it by some number, if you want to differentiate it, c will go down, and then you repeat the whole function again in front of it. And by the way, is this formula giving you the correct answer even if c is 0? Yes, do you remember what was the derivative when c was 0? It's supposed to be 1. Now assume that the derivative should be 0. If I put c equal to 0 again, this becomes 0. So I really don't need to emphasize that c is not 0. Because if c is not 0, this is the answer. If c is equal to 0, the answer is supposed to be 0, but this also gives me 0. So I don't need to exclude that. So I will put it back again. And then I know this question mark now. This question mark is c e to power cx. And then in the book, this is only given, and in the formula sheet, this is the only one given. The reason is clear, because if you know about this formula, you can immediately get this formula back. The only thing that you need to do is to replace c with 1. If you replace c with 1, this function becomes that. This becomes 1 times e to power 1 times x, which becomes exactly this. This is why you do not see this. You do not see this in the formula sheet, but you need to know that, okay? So let me just make it clear. This becomes e to power cx. If I ask you what is the derivative of this one, c goes down, and then I repeat the whole function itself in front of it. Okay? Is that understandable? Okay, so, but if you want, I can write something with red, even though I know that red is not a good thing. So can you tell me what is the derivative of e to power x? It becomes e to power x. What happens if I have e to power minus x? Can you tell me? Now you have this formula. In your head, you need to replace c with what, which number, so that I get this?
-1.
-1. So if c is -1, this will give me this one. If c is -1, this becomes -1 times e to power minus x. But minus, I can write the minus sign here. Yes? Oops. So this becomes minus this. I want you to remember these things exactly. But of course, if you are patient, you can always have one single formula and got these two formulas yourself. But still, I am giving you a lot of stories. I haven't talked about the real stuff yet, yes? Because I want to know what happens if I have any other number except this particular number in the base, then what I should do, okay? I haven't answered that question. It is a little bit more involved, okay? Any questions so far? Okay, so now let me give you some examples and before actually going. Again, if you don't like this stuff, even though they are exactly in the book, but you need to know this example. This is something that you will face in the exam. So, okay, let me write example. I want to give you a little bit of time. Hopefully, you can do it yourself. Differentiate. Number one, f of x is equal to 2e to power x minus e to power minus x plus x squared minus the square root of 2. Okay, let me do this one myself and then I will give you two for you. This is very simple. So what should I do? This is the sum and difference of a bunch of functions, yes? Subtraction, addition, subtraction. So I need to take them one by one separately. The derivative of this one has a constant here. It's a multiplicative constant. According to this rule, that's not a problem for me. I just keep it there. So if I want to differentiate this, f prime of x is equal to, this becomes 2, and I concentrate on the derivative of e to power x. Hopefully this is very famous for you by now. This becomes the same function. Nothing changes. But the next one, I have a negative sign here, and I have e to power minus x. You can separately have this in mind to do it quickly, or every time you need to replace c with -1 and redo it. I don't recommend that to you. I want you to understand that, but I think I would use this one. So the derivative, so I have a negative sign here. The derivative of e to power minus x, according to that red line, is minus e to power minus x. And the derivative of this one is actually the very old lesson now, so it is 2x. And the derivative of a square root of 2 is 0, because it's a constant. And then I would simplify this a little bit. So this becomes 2e to the x, minus times minus becomes positive, e to the power of minus x, and then I have 2x and nothing else. So that would be my derivative. Yes, understandable? Okay, let me give you two more and wait for you a little bit. These are also very simple ones, actually. So number 2, f of x is equal to let me write it in this way. E to power x plus 1 to the power of 2 multiplied by e to power minus 4x. We want to differentiate this. Now, I think this is a little bit, so let me do it next one. Okay, let me write a simpler one for you first. So number 2, f of x is equal to, and I will come back to something like this. E to power, let me write a little bit more. Okay, let us practice. This is important for the exam, by the way. These kind of questions you will get in the exam. So please do this one. And number 3, I would write the other function. Let me change the name of the function. Don't think that it should be always f. Yes, g of x is equal to you start doing that, so I'm writing. Don't spend time on writing the questions. Just do them one by one. Okay, let me write more now. And that was, now I will write this one here. Let me call it h of x. What did I wrote? I think it was e to power x plus 1 to the 2 multiplied by e to power minus 4x. Number 5, let me call it k of x. What happens if I have this? 5e to power 3x plus 2e to power minus 2x minus 1 divided by 3e to power 10x. Something like that. So I want to give you a little bit of time, 5 minutes, to at least start thinking about the problems yourself. So you see again, even though this is a simple formula, you might think that the diversity of the problems that we can solve only using this formula is very limited. It's not that limited. You still can solve a little bit harder problems using those. Okay, I can give you a little bit more time. Okay, so because I want to finalize this lesson, let us just start doing it. So what should I do here? It's not a complicated problem. By the way, I told you that every information, there are many information that I presented here, everything is in the book. But for the exam, if you want to watch the videos and then see what is important for the exam, only what I wrote as example will be a question, a type of question that you will face in the exam. But of course, if you are interested in mathematics, you shouldn't be very convinced if I just write this and simply write, okay, memorize, this is the formula. You need to know what is the meaning behind that and or how we can get those formulas. Otherwise, of course, you don't like mathematics. And you don't have to like mathematics, but I have to present it in a way that you understand where the formulas are coming from. But at the end of the day, you need to be able to use the formulas for the questions in the exam. Okay? Okay, so here I want to differentiate this function. Again, I have the difference and the sum of three functions. So I have to do them separately. For this one, we learned the formula today. For this one, we learned the formula today. For this one, we learned the formula a few sessions back. Yes? So it's very simple. So let me write number 2. Okay, now can you help me to write it down at least? So what is f prime of x here? What is the derivative of the first one? It is e to power 2x. So what the formula tells me, this constant should go down, and then I repeat the function itself. As simple as that. So it is 2 e to power 2x. And then I go to the next one, it is negative. What should I do? Minus 2 goes down, and then I repeat the function. But when minus 2 goes down, there is another minus sign here, so it becomes positive. Positive 2 e to power negative 2x still. And the next one is just the old formula. So 2 goes down, will be multiplied by 5, and 1 unit will be subtracted from the exponent. So it becomes 10x. Okay, how many of you got this right? Okay, that is good. Number 3 is also you should be experienced. I have talked about these kind of fractions before. But the only thing is that in those problems, we didn't have e, we had only x, but now we can actually mix them together. This is not a real fraction, even though it is written in the form of a fraction. You need to imagine that these are multiplicative constants. Instead of imagine it like this, you can imagine it first as what? 5 over 3, and then multiplied by my function. So let me stop here. Do you understand that this is equivalent to what I wrote there? Yes? Everyone? Okay. And then the next one, the same. 14 is the denominator. I can write it as minus 1 over 14 e to power minus 7x. And then I have 10x squared, and then I have minus 2. So you see, I haven't started differentiation yet. I reduced the form of a function in a form that I can use the roots. And now I start differentiation, yes? So tell me what happens. F prime of x is equal to what? 5/3 is there. So let me write this. You don't need to write it in the exam if you can do it in your head. But 3 goes down, and I will repeat the function in front. That is what rule tells me. This is a multiplicative constant. -7 goes down. I repeat the function in front. 10 is a multiplicative constant. According to this rule now, 2 goes down. X becomes to the power 1 unit less, which is 1, and I don't need to write it. And then the derivative of this is. Yes? And let us simplify, because this is very good to simplify here at this stage. This 3 in the denominator, then that 3 are cancelled, so 5 is left multiplied by this function. -7 and minus sign becomes positive. 7 and 1/14 can be simplified to 1/2, and e to power -7x. The next one becomes 20x. This would be the answer to this problem. Oh, how many of you got this right? Okay, not that many. If you don't understand, please let me know why. Okay, that is your own responsibility to ask questions, yes? Okay, so the other ones are a little bit more harder actually. So let us see how does this go. But if you have studied the lesson so far correctly, in principle, the ideas are clear for you. Okay, can you help me, for example, for number 4? First of all, tell me, I want to test your understanding. Can I start differentiation right away? No, if you can in math 4, but not here. The reason is that this is not a sum. This is not a difference. It's a product. So you don't know the rule for the product. You know that f plus g prime is f prime plus g prime. You know that f minus g prime is f prime minus g prime. But still you don't know what will happen for f g prime. This is something that you will learn in math 4. But it doesn't mean that you cannot solve it. You have to solve it in a different way. And that is not that hard. Can you tell me what to do? Any volunteer? What should I do first? Because in this form, I cannot do differentiation at all. Because that's a product of 2 functions. And the product of 2 functions derivative is a math 4 lesson. Yes? So we don't know. So what should I do now? Yes?
Expand and then multiply.
Multiply, exactly. So this becomes the quadratic rule. This becomes e to power the first one to the 2 plus 2 times the first one times the second one plus the second one to the 2. I know that you shouldn't write these things. They are very trivial, but let me write all of them in detail. You don't have to. Okay, now tell me, what is e to power x to another power 2? What can I write instead of that? Yes? 2x, because the exponents have to be multiplied. And then 2 times 1 is just nothing here. And then 1 to power 2 is 1, is e to power minus 4x. But still, I cannot start differentiation yet because it is a product again. So, but I know how to do. I multiply this inside. So let me write everything in detail. Please do not write all these details in the exam. Don't get used to this because it becomes very tedious. 2e to power x, e to power minus 4x, plus 1 times e to power minus 4x. I'm writing it because I want to make sure that you really understand what's going on. So here, what can I write here? Can I differentiate right now? Again, no, because this is still a product. But this is one type of product that can be combined into one term. Okay, so what's the answer to this product? Minus 2x. How did you realize? Because you said that the bases are the same, so I add the exponents. 2x plus minus 4x is nothing except minus 2x. So what happens for the next one? X plus minus 4x, it becomes? Minus 3x. 1 times anything is just the same function. Now everything is ready, I can start differentiation. So the process from here to here is nothing about derivative at all. It's just simplification and expansion. So now I differentiate, and differentiation is very simple now. You can do it in your head. What is the derivative of the first part? Yes? Any questions? Minus 2 goes down, and then I repeat the same function in front. Here, minus 3 goes down, but there is a 2 behind that already. So what happens? Oh, sorry. It becomes minus 6e to power minus 3x. This one, minus 4 goes down, minus 4e to power minus 4x. So this is the derivative of this function. Is that clear for everyone? Okay. And then let us do the last one and then go to the next lesson. So do you have any suggestion? Do you remember what? This is a real fraction, by the way. But that is one type of fractions. Again, you cannot solve it right now because there is another rule called the quotient rule. This is the called product rule. The quotient rule it's also math 4. But even if you know math 4 lesson, it is not that easy to use this rule. I will use the method that you learn here. Okay, do you remember what we're supposed to do? Not remember, or do you know what to do? No one? The idea is like expansion. This is not in the formula sheet, but I repeated several times when we were dealing in chapter 1. So if we have A plus B divided by C, what can you? Yes, you can separately divide. Yes, so you can write A divided by C plus B divided by C. So remember, if you have a fraction, these are harder questions in the book. If you have a fraction whose denominator is one term, remember this idea that you can separately divide. This is a very important idea. This is not in the formula sheet. If you want to write it down, let me write it for more complete one. A plus or minus, it doesn't matter. B plus or minus, C plus or minus, whatever, divided by D. You can write it as A over D separately, B over D separately, C over D separately, and continue. And if it is plus, put plus. If it's minus, put minus. Plus or minus, etc. So this is not in the formula sheet because this is not something that it should be there, of course. This is just adding fractions, yes, with the common denominator. Okay, so the first thing, so let me put a star. Apparently nobody knew what to do, so it needs a star here, So that if you want to review, remember that you couldn't solve it in the class. So this becomes 5e to power 3x divided by 3e to power 10x. Yes? And then I go to the next one. 2e to power minus 2x divided by 3e to power 10x. And finally, minus 1 divided by 3e to power 10x. Yes, and I think that now it becomes clear. First of all, this 5 and 3 can be written as a multiplicative constant 5 over 3. But can you tell me what happens for e to power 3x?
E to the power minus x.
Exactly. Why? Because these are the same base. So I write the base, but because this is division, I have to subtract what is in the numerator minus what is in the denominator. So what happens? It becomes minus 7x. So the answer to this part is nothing except this. And the next one, 2/3 is the multiplicative constant here. Okay, can you tell me what happens now?
E to the power minus 12.
Minus 12, yes, because minus 2x, I am dividing minus 10x to minus 2x divided by minus 10x becomes minus 12x. And then what can I do here? Anyone else? Yes?
You can move it up.
Move it up. So it becomes minus 1 over 3 e to power minus 10x. I just moved it up, yes? Is there any questions in this calculation? Okay, so remember this. This was an important question apparently for all of you. So it is, now everything is ready, I start differentiation. Everything is ready. Oh, sorry, I missed an x here, yes. There should be an x here. Okay, I differentiated, so k prime of x is equal to 5/3 is a multiplicative constant, and I move -7 down, e to power -7x, and then I have 2/3, -12 goes down, and I have e to power -12x, and then I have -1/3, -10 goes down, and I have e to power -10x. Differentiation is finished at this point, but let us just do some calculation to simplify this. K prime of x is equal to 5 times -7 is -35 divided by 3. And then I have e to power -7x in front. This one and this one are simplified. It becomes -4. I multiply it here, it becomes -8, e to power -12x. And this one multiplied by that one is positive 10/3 e to power -10x. So yeah, so that is a little bit harder A-level question, but it's at the level of the book. Any questions so far? Okay. But now the story begins again. So we want to go back and solve this problem. What happens? I told you what happens if you want to differentiate e to power x. E is this mysterious number, yes? So if e is, I don't know, 2.718, I think, etc., etc. If I ask you what is the derivative of this function, you tell me it is itself. But now, if I change this number to 2, what would be the answer? This we don't know yet. What would be the derivative of 2 to power x? We don't know. What would be the derivative of 3 to power x? We don't know. You see, only if this base is this very particular number, we know that its derivative is equal to itself. But we still don't know what will happen for the derivative of these functions if I change this to another function. So this is the question that we want to answer. But this is not that straight that we can answer it, okay? We have to go through a little bit of revision of Math 2C about logarithm, okay? So let me clean this. We don't need this. At least we can start. Logarithm. So crash video. So, do you remember what a logarithm was? We studied that in Math 2C. And actually we did good. If you remember, we solved a little bit hard problems there. Okay. You were more excited that time, yes, than this year. Okay. Yeah. So what was the definition of the logarithm? Yes, when you say that, the logarithm, first of all, hopefully you remember it was log, and then you have a number here, a, and then you have another number here. This is called the base of the logarithm, and there are some limitations for these numbers. The number that's sitting in front here cannot be negative. The number that's playing the role of the base not only cannot be negative, it cannot also be equal to 1. So there are two limitations for the base. Base should also be positive, but not equal to 1. If you respect all these conditions, then you're allowed to talk about, you don't need to write capital A, by the way. I don't know why I wrote capital A. It's LOG. So, what is the meaning of this? When you say that this is equal to x, it means that b to power x is equal to a. And the other way around. So that was the definition of the logarithm. Yes? For example, if I ask you, what is logarithm of 8 in base 2? It means give me a number so that when I raise 2 to that number, it becomes 8. Yes, this is easy. I can do it in my head, but most of the time I cannot do it because these are not very clear numbers. So here, yes, you are right. This becomes 3. Yes. For example, if I ask you what is the logarithm of 1/16 in base 2, I am asking you what is this number so that when I raise 2 to that power, it becomes 1/16. If it was not 1/16, it was just 16, it was simple, it was 4. But now you want to make it 1/16. If you remember about the power rules, you immediately realize this is -4, yes? Because if I ask you what is 2 to power -4, how do you calculate? This is a negative exponent. I have to put it in the denominator, make it positive, and everyone knows 2 to power 4 is 16, so this becomes 1/16. So that's a correct number, yes? Because 2 to that -1 is this one. And there is a convention going on. The convention is that if the base is 10, we don't write it, yes? So convention, if b is equal to 10, we don't write the base. Yes? So whenever you see log of a in base 10, don't bother to write it in that way. We simply write log of a. And log of a is the button on your calculator. Log in other bases are not included in the calculator, but you can calculate it. We will talk a little bit about that later. Okay, but this log bottom is on the calculator. It means that this is automatically base 10. Okay? For other ones, we don't have it in calculator, but still we can use the calculator to calculate them exactly. So that's also a convention. But there are some formulas that was for the logarithm. I want to review them a little bit. So the first formula, let me write it here. Okay, so what happens if I have a logarithm of number 1 in any base b? So here b, so let me write it is in front. So if I ask you what is logarithm of 1 in any base b, if of course b is positive, because if b is not positive or it is equal to 1, it is not defined in the first place. But assume that b fulfills those conditions, and I'm asking you what is logarithm of 1. What is the answer? 0. Yes? Is that clear? So logarithm of 1 in any allowable base is equal to 0. Why? Because b to power 0 is 1. Yes? So that is you need to know. Logarithm of 1 in any base, in any allowable base, is equal to 1. The second one is the logarithm of any number in its own base. Again, b should fulfill these conditions. Should fulfill these conditions. That it cannot be negative, it cannot be equal to 1. If you respect those rules, then what is the answer? 1. Yes? The logarithm of any number in its own base is 1. Why? Because b to power 1 is b. Yes? And number 3, what was the other one? I want to use here. You see this x is equal to this. So take it away, so it becomes b empty space is equal to a. X is on the other hand equal to this guy. So instead of this empty space, I will put this. It becomes logarithm of a in base a. It's a very, very important, actually that's the definition of logarithm. So if I raise b, any number, to a log with the same base here, everything cancels out, and then you will have a. Yes? So let me write this here. If we have b to the power of logarithm of a in base b is equal to a, of course you need to respect the conditions. B should be positive. Let me write in order. A should be positive, b should be positive, b shouldn't be equal to 1. If you respect these rules, these conditions, then that is fine. Is that clear? Do you remember another very important formula for the log? I want to write 3 more. It was in the formula sheet, but we talked about them last year. Yes?
I think if it's a to a power, you can write to log.
Yes, I want to write this at the last one. Yes. But there are 2 intermediate ones. One important fact is what happens of a logarithm of a product. So if I have this situation, number 4, assume that I have the logarithm of the product of 2 numbers in base b. Okay? Of course, here x should be positive, y should be positive, b should be positive, b shouldn't be equal to 1. If you respect all these limitations, then there is a nice formula for this. Logarithm turns a product into a sum. So it becomes the logarithm of the first one, logarithm of the second one, but not product, sum. So the logarithm of the product of 2 numbers is the sum of the logarithms. And then we have, do you remember now for the division? So logarithm of x over y with exactly those conditions. X should be positive, y should be positive, b should be positive, b shouldn't be equal to 1. What can I write? Do you remember? What happens? Logarithm changes the product to a sum, and then changes the division to minus subtraction. So it becomes logarithm of x in base b minus logarithm of y in base b. And then the last one that I want to write was the one actually called Johan actually mentioned, and this is this one. If I have a to some power up there, and then I have a base, this number, whatever it is, let me change it to p, because usually we use n for natural. There is no reason that it should be natural. It can be any number. You need to take this one to the back and multiply it by the logarithm. So it becomes p multiplied by logarithm of a in base b. So of course, p is a real number, any number that you like, but a should be positive, b should be positive, b shouldn't be equal to 1. Under these conditions, you can just write this formula. There is also another formula, even though it was not in the book, I talked about that. That is the change of basis formula. I will come back to this, but let us at least start something, because probably we will not be able to finalize this today. So you see, it was a long journey if you want to really calculate the derivative of this simple function. Okay, now I want to, this was a little bit of review of what we learned in Math 2C, but now we need to learn a new logarithm, which is called the natural logarithm. Okay, so let me change the title. So I will, natural logarithm. So what is a natural logarithm? A natural logarithm is also written as simple. Do you remember I told you that if the base is 10, you don't write it, but if the base is the Euler number, it becomes a natural logarithm. As simple as that. Yes. So the natural logarithm is this. A logarithm in base e, Euler number, is called a natural logarithm. And it is denoted by ln instead of log. Okay, so when you say ln, of a, it means logarithm of that number in base e. So instead of writing too much, the first principle for being a mathematician is to be lazy. Yes. So you don't like to write a lot of things. So it's ln of a. So you immediately invent a new symbol, so you don't need to write it over and over again. But this is the thing. So you shouldn't get confused. Whatever you see here on the board also works for the natural logarithm because it's a logarithm. The only thing is that the base is e, and when you see ln of a, it means logarithm of this number in base e. First of all, do you think that this e is allowed as a base?
Yes.
Yeah.
What are the conditions? The base should be positive and shouldn't be equal to 1. But we know that e is approximately 2.7, so it is positive and it is not equal to 1. So it is it is allowable for being a base. Okay, but can a be negative here in front of ln? No, because if this a is negative, it means this a is negative. But we know that in front of a log, we cannot have a negative number. So this is crucial. There is only one simple condition. You see, instead of writing a is positive, b is positive, b is not equal to 1, I just reduce it to one condition. So when you talk about ln of a number, that number should be positive. Yes? I know that you're a little bit tired, but we need to finalize it, otherwise it doesn't work. Okay? Now I want you to translate all these formulas into the form of ln. Okay? So what we can do? Let us do it together. So how should I write? I want to keep that one. So let me clean this. So let me write this up there. So we learned that ln of a is equal to logarithm of a in base a. First, answer this question to me. When you say ln of a is equal to x, what does this mean? Logarithm of ln of a is equal to x. It means that in a scratch paper, logarithm of a in base e is equal to x. What can I conclude? E to power x is equal to a. So this you need to write here. And the other way around. A should be positive. It's very, very important to, I think this is given in the, I don't remember exactly, but this is a very important formula. So ln of a is x. It means e to power x is a and the other way around. Yes? Okay. Now let us translate them quickly one by one. I will repeat this a little bit next time. At home, probably. Yes, schools are closed again. So here, number one, translate it for me. What can I write instead of the first one? What can I write? I can write ln. I ask you, what is ln of 1? Answer me.
0.
It's 0. Why? Because ln of 1 is logarithm of 1 in base e. Who cares about base? As far as this is concerned, so this is met, we are done. So ln of 1 is a very important result. It's 0. Okay, now tell me the next one. Can you translate the next one? Yes?
ln of e equals 1.
Very good, thank you. ln of e is 1. Yes? Because when you say ln of e, it means logarithm of e in its own base e. So these are two very nice formulas. ln of 1 is 0, ln of e is 1. What is the third one? Can you translate that one for me? E to power ln of a is a. Very good. E to power ln of a is a. Is that understandable for everyone? I am just changing the name of b to e. Yes? That's it. And then instead of writing logarithm of a in base e, I simply write ln of a. But there is a condition for this. What is that condition? A should be positive. Because these two conditions are automatically met for e. Yes? So a should be positive. Translate the fourth one. What is that one? Yes, ln of product is equal to ln of the first one plus ln of the second one. Yes, but here there are some limitations. X should be positive, y should be positive as well. Number 5, ln of x over y is simply ln of the numerator minus the ln of the denominator. Again, the condition is that x should be positive, y should be positive. And finally, number 6, ln of a to power p. P goes back and be multiplied by the number that you get from ln. Yes? And then here, p is a not real number, any number that you like, but a should be positive. And there is a separate button on your calculator, it's ln. So there are two buttons on the calculator. One is log, which calculates the log in base 10, and there is a separate button on your calculator, which is called ln. And the number e, by the way, number pi is on your calculator. There is a button on the calculator which gives you pi. There is also a button on your calculator. You need to find these things, which gives you the Euler number. Okay, that's also on your calculator. I will stop the lesson here, and then still this question is left. So this is a real part of mathematics. You see, that's a very, very long journey if you really want to find something very simple. It's not that simple. Okay, no questions? Thank you very much. So bye-bye. I want to end this.